Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at devices in a small network. We'll be discussing small network topologies, device selection for a small network that includes cost, speed, and type of ports and interfaces, expandability, operating system features and services. Then we'll talk about IP addressing for a small network. We'll look at redundancy in a small network, and we'll end with traffic management. This episode is part of my series on Introduction to Networks for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. If we look at the companies in the world today, the majority of them are smaller companies. And what we mean by smaller companies are anywhere from 10 upwards of a couple hundred devices on their network. We're not looking at a medium-sized network. Medium, it would be typically like a couple hundred to a couple thousand. Large network is a couple thousand up to maybe 10, 20,000. And a really large network, you're talking hundreds of thousand devices. These small networks, like I said, you're looking at 10 to 20 up to maybe 200 devices on your network. That's what we consider a small network. A small network is typically simpler than a large network. And it's just because you don't have the number of people, number of devices on your network, plus you typically don't have the budget of that big network. You're not supporting all of those people. You don't have all the money to give you the devices to support hundreds of thousands of users. Oftentimes, your small network only has one wide area network connection. You only have one connection to your ISP. That ISP could be DSL, cable, Ethernet. We also see wireless starting to come in, either cellular or some sort of lease-based wireless to give you that last delivery to that location. A large network, they require a lot of infrastructure. They require huge IT departments. We're looking at sometimes 10, 20, 50, 100 people on staff in these IT departments. Where a small company, they usually have one or two people, if that, on staff. A lot of small companies today with small networks, they outsource their IT support. They go to some sort of contractor from the outside to come in and do that. Small companies don't need this dedicated staff. They just need people to come in maybe a couple hours a week, do maintenance on that, and anytime they need to make a system upgrade or a change to the network, then they'll go and they'll get some sort of contractor or IT consulting people to come in and do that. And they find that's a lot cheaper and a lot quicker typically than having somebody on staff do that. Like a large network, a small network needs planning. The idea to come in and how are you going to set up your network? Are you going to have some routers and switches in there? What's the basic plan for this? And most of the time, the decision always comes down to cost. Looking at how much is this going to cost? Will we be able to realize improvement and increase in profits to make this expenditure worth it? Typically referred to as like a return on investment. Some of the things that we need to look at when we're selecting our devices, like I said, is the cost. We have that $50 router you can buy from a big box store online. You can go and look at Cisco devices where you're looking at hundreds, if not a couple $1,000s each, which is appropriate for that. Then you have, what is the speed of that? You can buy fast Ethernet switches, which are maximum speed of 100 megs. You can buy gig switches, which is a maximum speed of gigabit or 1,000 megs. You can even buy 10 gig switches, which is 10,000 megabits per second. You have to figure out what the needs of your companies are. Are you transferring large files? Maybe you're a print shop and you have 20 gig files that are really big you need to transfer between the computer and the proofer or something like that. Or are you just a smaller business that does email and web traffic and that's all you have? And you could get away with a fast Ethernet port at that point in time. Another point is expandability. Looking at the future. Is your company going to grow? we all should assume our company is going to grow, maybe not necessarily with the number of employees, but with the amount of network traffic and the amount of network devices. If we look at a company nowadays, we see that we have desktop PCs. We have voice over IP phones. Then we throw in some printers, scanners, maybe IP cameras, environmental sensors. We have the Internet of Things. All those devices need IP addresses. Maybe you're starting to use some home automation, some sort of automation in your business. Those are all using IP addresses. It used to be figure out the number of IP addresses you need and then double it. In today's world, I'm willing to say you need 4 to 5 times what you think you're going to need in the future, because we're all connecting up all these devices. I know some people that say figure out how many IP addresses you're going to need, add a 0 onto that. That's the number you should plan for on your network. Then you also need to look at the different operating systems and features. Each operating system, each device has different characteristics. They have different strengths and weaknesses. You need to figure out which device is best for your company. I hope you're liking this episode on devices in a small network. If you had the time, please leave a comment and let me know what you think about these devices when you use them on a small network. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. When we look at IP addressing for your network, every end device on your network needs an IP address. It needs to be a unique IP address so you can't reuse those IP addresses. And like we said, you need to figure out how many you're going to need on your network. And then I add in a bunch of extra addresses because we're always adding stuff onto our networks. And that's what you plan for. You have to think about that. Servers, other peripheral devices like phones, desktop PCs, mobile devices, printers, scanners, IP cameras. They all need IP addresses. What are you going to need in your company? Then, do you have any intermediary devices like routers or switches and access points? Stuff like that. We have to give those IP addresses because you want to be able to manage them remotely. And of course, once you've established your IP addressing, you need to document that. Now, there's software out there, there's third-party tools out there, but a lot of times these cost a good deal of money to get into. Microsoft Windows has a couple tools built into that, but it's for larger organizations. It's for tracking IP addresses. It ties into the DHCP and the Active Directory, and it's a great tool, but it's made for bigger organizations. A lot of times, smaller organizations with small networks, I see Excel spreadsheets. That's what I see to document your IP addresses, what IP addresses are used where, what networks we're using, what range of addresses we're handing out on our DHCP servers. That's how I see the documentation being used. Now, the trick is to continually update that documentation. As you make changes, you have to go back in there and make changes. Oftentimes, I see people initially set up their documentation and then they don't change it ever again. Even though their network has evolved into different scenarios and settings and configurations, they never update their IP documentation. And so when you need to make a change and look up something, you don't have that documented. So another recommendation here is make sure you're always updating your documentation for your IP addressing. Redundancy is required in order to maintain a high level of reliability and availability on your network. We want to make sure that your network, if it has a problem, that it can still stay up and running. One phrase I like to say is, as long as you give the illusion that everything is okay to your end users, you're doing a good job. Maybe behind the scenes you have network failures, maybe something caught on fire, whatever's happening behind the scenes, but as long as that end user thinks, hey, nothing's going on, you're doing a great job. And so this redundancy helps, but redundancy also comes with a cost. And what I mean by cost here is it's dollars, because redundancy, you typically need to have duplicate equipment. You need to look at your business. You need to understand your business to see how much redundancy is actually needed. If you're working in a business where they're processing real-time orders and real-time credit transactions, you probably need a high level of redundancy. You probably are going to invest a lot in infrastructure redundancy, external connections, connections to your WAN, redundant servers, redundant switches, redundant routers. You're going to go in and invest that. If you work for a manufacturing company and they could survive being down 8 hours without having their computer network, you probably don't need a lot of redundancy then in your network. So you need to understand your company's needs, and then you can decide what type of redundancy you need. The goal of good network design is to enhance the productivity of employees and also minimize the downtime of your network. What you want your network to do is support your employees to do what the business needs to be done. Now, a lot of times it's manufacturing parts, ordering, getting pieces in, the production of those parts. You need that network to enhance that employee productivity. If the employees can do their job, then the company can make money, and that's the ultimate goal of the business is to make money. Now, if your network goes down, you're obviously, depending upon your business, may not be able to meet those business goals. As we look at your routers and switches should be able to prioritize certain types of traffic. At the top end of the priority level should be your real-time data that is passed through, where if we had to resend some of the data, it would probably come in after the point it was needed. And what this here is voice, where if I'm talking to you in a conversation and we have to rebroadcast a couple words, it might come in a second or two later, making that conversation kind of hard to follow. And so this voice traffic gets prioritized over that. At the bottom end is slower traffic, and a lot of times you can consider this web traffic, FTP traffic, where if it takes an extra second or two to get some FTP file downloaded, if it takes an extra second or two to get that web page loaded in, it's not really going to affect the overall message that much. Typically, what we call this is quality of service. Adding in this quality of service, or QoS, to make sure that the high priority traffic makes it through the system. It was my pleasure to provide you with this wonderful episode on devices in a small network. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks for the CCNA. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on Introduction to Networks for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.